We'll proceed in Jacobian, reverse Jacobian. We are trying to do something in reverse Jacobian. Jacobian and reverse Jacobian. So we are trying to prove the Jacobian what it is through the cross product. Is it really like if I have basic integration? Basic integration is limit integrand differential. When we go with the method of substitution in calculus, then if we have dx, dy, x and y typically, we transform into another coordinate system. Suppose it is theta and r, that is polar coordinate system, or u and v, theta and r, or u and v. So if it is theta r, then it is integration along a region. Many times we have discussed about it. Integration along a region, integrand differential. Now when we go for method of substitution, then integrand x and y we replace with u or v, that is the new coordinate system, or theta and r if we are taking polar coordinate system. Now in that sense, integrand we replace. Now differential dx dy we cannot replace directly as d theta dr, or x equal to r cos theta, y equal to r sin theta, then dx not possible. Dx, x is r cos theta, not there are two variables r and theta. Dy, where y is r sin theta, r and theta, two variables. Now how we can do this? We can do this as dxy. Dxy is a plane. Dxy, this is x-axis, this is y-axis, and this is z-axis. Then xy plane. Dx dy is dxy plane. Now dxy plane I can convert into d theta r plane. But directly I cannot write dx dy as d theta dr. There is something that will be appended to the d theta dr. That is called Jacobian. So dxy plane is nothing but dxy plane by d theta r plane into d theta r plane. D theta r plane is written as d theta dr, and this is the extra thing that is attached as far as the kind of transformation of differential one coordinate system to other coordinate system is concerned. In that sense, dx dy can be written as dxy plane by d theta r plane into d theta dr. The limit we have to settle down very meticulously, very cleverly. We cannot settle down limit straightforward the way integrand is done. So differential and limit, that should be settled very cleverly. Now this Jacobian dxy plane by d theta r plane, reverse Jacobian d theta r plane by dxy plane. If these two Jacobian, if I multiply, if it becomes 1, then actually this Jacobian calculation is correct. Okay, reverse mapping. D, okay, what is mapping? Now consider that we are taking polar coordinate system. Now this is xy plane. This is theta r plane. In xy plane, I have a circle, and this circle is mapped into theta r plane as a rectangle. This is the concept of method of substitution. Because if our reason when we are doing fxy, dx dy and integration along a region is circle. In our example, may not be always circle. Means if I have xy plane, on top of it I have a surface, then we are calculating the volume of the surface only the intersection region where it has intersects, where on the xy plane I am taking set of x comma y points. Those set of x comma y points belongs to a circle only. It must be x and y point I must take from a circle only, not outside it. So from that circle, all the points would go and map into the surface, and whatever region it forms, that region Now it go down and touches xy plane. Whatever comes in between, that is the volume. So fxy dxy plane integration over the region on the xy plane, that is a circle. Now if it is a circle, then xy plane, the limit region is a circle. Now this circle would going to map into a rectangle in theta r plane. At the end, idea is that the region what we take on xy plane, it should be rectangle, it should not be a circle. How come you can say it cannot be a circle? I want circle, right? You want circle, but as far as integration is concerned, there is limitation. X and Y are two independent components. Z or fxy is dependent upon X and Y. In that scenario, X and Y must not depend upon each other. But here, if region is a circle, then y is dependent upon x. If x is minus a to a, that is radius of the circle, then y is minus a square root of a square minus x square to plus a square root of a square minus x square. Y is dependent upon x. It must not be dependent upon x. If I map this circle in theta r plane with a transformation function that is capital T, or that is x equal to g theta r, that is r cos theta, y equal to h function theta r, that is r sin theta, then the circle would map to a rectangle in theta r plane. Now convert everything in theta r plane, then independent component is a the reason on the earlier independent component was xy plane. In xy plane, the calculus region was a rectangle. In that calculus region was a rectangle. In xy plane, the calculus region was a circle. Now this region I map it to theta r, that is a rectangle. Now consider this is theta r. What about other stuff, that is an integrand and differential? Everything we are converting into theta r. Just to make that limit region should be rectangle, we are changing everything. So limit region must be rectangle. At least x and y or theta and r, they should be least dependent upon each other. Here they are tightly dependent upon each other as far as circular region is concerned. Now idea is, what is dxy by d theta r, that is the Jacobian. When we modify the differential part dx dy to d theta dr, dx dy is nothing but dxy by d theta r into d theta r, d theta dr. This is dxy by d theta r is the Jacobian. Then we say that that is nothing but, if this is xy plane and this is theta r plane, then there is a rectangle in theta r plane. This rectangle is connected to a circular region in xy plane. Connected. Like I give example, like there is a very big robot and I have very small robot in my hand. Exactly like that. If I twist the hand, then big robot's hand gets twisted. If I rotate the head, then the head gets rotated. This exactly proves that they are connected to each other. Similarly, the xy plane circle is connected to theta r rectangle. If I make a small change in theta r rectangle, change is seen in the circle in xy plane. Now dxy plane by d theta r, dx by d theta means if I make unit change in theta, how many unit change I see in x, dx by d theta. Dxy plane by d theta r plane, if I make 1 unit of area change in x theta r plane, that is the rectangle, if I make 1 unit change, okay, then this 1 unit change brings how many unit change in the circular region in xy plane, dxy plane by d theta r plane. If I take any position vector p on the xy plane, or I can consider this is theta r plane, and theta r plane is independent component upon which xy plane is sitting. Now this xy plane is based upon theta r plane. If I take any point P on the xy plane circle, if I take any point P, then dp by d theta cross dp by dr is nothing but P is position vector on xy plane. dp by d theta cross dp by dr, dp by d theta cross dp by dr is nothing but dxy plane by d theta r plane. Where we have to prove it, then we will go to cross Jacobian. Okay, now I have taken any point P on the xy plane circle P, any point P. Now that P corresponds to a one point in rectangular region in theta r plane. One any point. Any point here correspond to P point in xy plane. It's a mapping. Now I make delta theta change in this point. So there is one point in theta r plane, and this is theta line and this is r line. Cartesian coordinate there also. Now in theta I make delta theta change, and in r I make delta r change. Now there are 3 points. Another point where theta is changed, another point where r is changed. Now this point is theta plus delta theta comma r. This is theta comma r. One point is there. This is theta plus delta theta r. This is this is this is theta plus delta theta r. This is theta comma r plus delta r. 3 points. Now this theta r, for theta r there is a corresponding point in xy plane circle as P, that is xi plus x comma y. That is nothing but x is function over theta r, x equal to g theta r. Y is function over theta r, y equal to h theta r. Now there is another point called, so this point x comma y P is nothing but g theta r comma h theta r. Now there is another point where theta has moved. Theta plus delta theta comma r. We can say delta x movement here, whatever. Now this point is another point along the theta. Theta plus delta theta comma r is mapped into another point. That point is g theta plus delta theta comma r. H theta theta plus delta theta comma r. Okay, this point is, or I can say, if this point is g, this point is g theta plus delta theta, sorry, this point is g theta r h theta r. Another point is another x and y where x is g theta plus delta theta, g theta plus delta theta r, h theta plus delta theta r. Now, if I take a line that is a vector now, then it will be g theta plus delta theta comma r minus g theta comma r. X point. Y point would be again h theta plus delta theta r minus h theta comma r. That is j component, I component of the vector. If this vector I called it vector A, then vector A, this vector I call it A. A is nothing but g theta plus delta theta comma r minus g theta comma r I plus h theta plus delta theta r minus h theta comma r j. This is a vector, a position vector. Now I have another point here. Point here is movement along r. So one point is theta comma r, one point is theta plus delta theta comma r, one point is theta comma r plus delta r. This point would not transform into g theta r plus delta, g theta r plus delta comma h theta r plus delta. Now from point P, if I take this as position vector B, as a vector B, one is vector A and one is vector B. In theta r plane, I have 3 points. One point is theta comma r, one point is theta plus delta theta comma r, one point is theta comma r plus delta r. This is one vector, this is another vector. Like this, that if I see it in xy plane, then theta comma r point here correspond to x comma y. That is g theta comma r comma h theta comma r. Another point is g theta plus delta theta comma r comma h theta plus delta theta r. Another point is g theta comma r plus delta r, h theta comma r plus delta r. This is a vector, this is b vector. Now a vector is g theta plus delta theta r minus g theta r. A vector. This is I component and j component is h theta plus delta theta r minus h theta r. Now another is b vector. B vector is is g theta r plus delta r minus theta minus minus g theta r. This is the I component. J component is h theta r plus delta r minus h theta r. A and B. So on xy plane, I have A vector, I have B vector, that is at any point x comma y. Now, if that is the case, then what is the area at that point? Area is nothing but A cross B. So vector A cross vector B is the area at that point. Now we calculated the area. Initial phase we are talking about dp by dx cross dp by dy, and that is dxy plane, that is the surface, d surface by dxy. This is what we kept talking. Now we'll go minutely now. Now this is the surface area at any point x comma y as far as xy plane is concerned. A vector cross b vector. This is not velocity surface area. This is surface area. That is g theta plus delta theta comma r minus g theta r I plus h theta plus delta theta comma r minus h theta comma r j. This is a vector cross b vector, that is g theta comma r plus delta r minus g theta r I component plus g theta r g plus h theta comma r delta plus r minus h theta r j component. Now this is a vector, this is b vector. If I do cross product of this, I get instantaneous momentary area vector at that point. This is the area vector. We kept talking about area velocity vector. This is the area vector. So if this is the surface whose base is a circle, if this is a typical surface for which we are trying to calculate the volume, then this surface at any point in this surface, then the circular region is xy plane, there it maps like a circle. On this point, if I take any point P, that coordinate is x comma y, at that point the momentary area vector is A cross B. I am not going to repeat it, it is very big. A cross B, A vector cross B vector. Now A cross B vector, we got the area vector, very nice. What about if I divide it by delta theta delta r? Then I can multiply with delta theta delta r, same as area vector. Area vector, what is A cross B? A cross B is same as A cross B by delta theta delta r into delta theta delta r. If that is the sense, then A cross B, whatever we have, now this A by delta theta, A by delta theta, A by delta theta cross B by delta r we can write. Or if no one is satisfied with this, at least we have now A cross B. A cross B is the surface area what we have calculated on xy plane by delta theta delta r. That is nothing but the area, that is the area in theta r plane into delta theta delta r, same thing. That is nothing but d surface area in xy plane by d surface area in theta r plane into d theta dr. We are landing up into similar situation. D from backside, we are going from backside. Now we have D surface area in xy plane by D surface area in d theta r into d theta r plane. D theta r plane, I can write d theta dr, and D surface area in xy plane, D surface area in xy plane by d theta r plane. Earlier integrand was dx dy or d surface area. D surface area I can write as d surface area by d theta r plane into d theta r plane. Same thing, we are coming from this side. Now we have A cross B by d theta dr. Same we can now write A by d theta cross B by A by delta theta cross B by delta r, since it is a multiplication. If that is the case, then what about A by delta theta? What is A vector? A vector is H. A vector is G theta plus delta theta, r minus g theta r by delta theta. It is something like differentiation. Something plus delta z. It looks like dg by d theta. G theta plus delta theta comma r minus g theta r by delta theta is dg by d theta. Cross now b vector h h h theta plus delta theta comma r minus h theta r theta by theta. Okay, b vector. Okay, this is, I talked about x component only. A vector by delta theta cross b vector by delta r. This is what we are saying. A vector has two components, x and y. X is g theta plus delta theta comma r minus g theta comma r by delta theta is nothing but dg by d theta I plus dh by d theta j cross now b vector, that is g theta comma r plus delta r minus g theta r by delta r. This is x component. A y component is h theta comma r plus delta r minus h theta comma r by delta r. Okay. Now, if I go with the normal differentiation function, first principle, then it becomes a it becomes a it becomes d. Okay. So it becomes dg by dr, dg by dri plus dh by drj. Okay. Now I have velocity vector. So now I have dA by dA vector, dA by d theta cross dB by dr. Okay, if that is the case, I'm sorry, it is not dA by d theta. I'm sorry about it. So it is dg theta r by d theta. This is what I can say. dg theta r means dp on xy plane. I have 3 points. One point is P where x comma y is the point, that is g theta r comma s theta r x y, g theta r x theta. Now if I have g theta plus delta theta comma r minus g theta r by delta theta, this is nothing but dp by dp, that is the position vector, dp by d theta cross same thing dp by dr. Now we came to same situation. D surface area by d theta r plane is nothing but dp by d theta cross dp by dr, where p is xi plus yj or dg theta r comma di plus h theta rj, that is xi plus yj. So dp by d theta cross dp by dr is nothing but dxy plane by d theta r plane. Okay, so that is dp by d theta cross dp by dr. This is the forward Jacobian. What is reverse Jacobian? This principle we can apply to find the d surface area by dxy plane also. We are finding dxy plane by d theta r. So if this is the surface area, if this is xy plane and this is the surface area which is z, that is fxy. Now we are trying to calculate the surface area by dxy plane. The surface area by dxy plane. Now any position vector, point P, if I take here, that is x comma y comma z, x comma y comma z. Now in xy plane, in x comma y comma z. Now there in xy plane, if I go along x-axis delta x, then there is another point P. I believe it can be an assignment. If I go along x-axis, or we can try doing another session, and I believe that will be the last session. Anyway, we are in 19th session. That would be the last session. So now we will try to prove in similar fashion in kind of normal 3D surface. Now we have Jacobian as d surface area by d theta r. That is nothing but dp by d theta cross dp by dr. That is actually a cross b by d theta dr. This is what we saw, and slowly we came to same from reverse side, we came to same fundamental dp by d theta cross dp by dr. D surface area, d surface area, d surface area by dxy surface area by d theta r. There is a reverse Jacobian also, reverse transformation. That is d theta r plane by dxy plane. If it really exists, reverse Jacobian, if it really exists, if this is a forward Jacobian, if xy is a function over theta and r, can y go with the theta r is a function over x and y, reverse transformation, and it should be one and one mapping. There should not be 2-point mapping to 1 point. If this reverse function is also true, then reverse Jacobian should be true. If x and y is a function over theta and theta and r is also indeed is a function over x and y, reverse, then reverse Jacobian should be true. Dxy plane by d theta r plane into d theta r plane by dxy plane should result in 1. This is what we are trying to prove. Now consider x equal to r cos theta and y equal to r sin theta. dp by d theta cross dp by dr is dxy plane by d theta r plane. That is kind of forward Jacobian. That is the forward Jacobian. So in forward Jacobian, now it resolves into r. R, if I take dx by d theta, dx by d theta, dx by dr, and we compute through matrix where top is dx by d theta, dx by dr, dy by d theta, dy by dr. If I calculate where x is r cos theta and y is r sin theta, this matrix would resolve in r, or dx by d theta I plus dy by d theta j cross product with dx by dri plus dy by drj. It would resolve in r. Now we are going to reverse Jacobian. Reverse Jacobian will be, we can calculate, and if it multiplies and it becomes 1, then reverse Jacobian or reverse transformation for this transformation actually exists. Okay, if that is the case, now what is d theta r plane by dxy plane? dr by dx, dp by dx, where p is ri plus theta, theta I plus rj, where p on the theta r plane is d is theta I plus rj, dp by dr, dp by dx cross dp by dy. This is reverse Jacobian. If that is the case, then theta I plus rj, d theta I plus rj by dx, d theta by dxi plus dr by dxj cross product d theta by dyi plus dr by dyj. If I do, it will resolve in 1 by r. Then only multiplication will be 1. Someone can now try. There should not be any hesitation in trying. Now, what should be the reverse function? If forward function is x equal to, if forward function is x equal to r cos theta, y equal to r, this is our example. This example is not available anywhere else. Please support us, plus 91. This, whatever the explanation we have given, d theta, how to calculate dxy plane by d theta r plane, and we started with the mapping the point and then calculating. Partial solution is available, not the full solution. Please support us. Plus 91 is India country code 9483160610. Plus 91 is India country code 9483160610 is the phone number. Now we are calculating reverse Jacobian. X equal to r cos theta, y equal to r sin theta. How I can say r in term of x and y, and theta in term of x and y. If that is the case, then x square plus y square equal to r square. R equal to square root of x square plus y square. This is the reverse mapping. Now x equal to r cos theta, y equal to r sin theta, then y by x equal to tan theta. Theta is equal to tan inverse y by x. Now it is solved. R equal to square root of x square plus y square. and theta equal to tan inverse y by x. Now, if this is the scenario, now we have determinant I have to find d theta by dx, d theta by dy, dr by dx, dr by dy. These are the two rows. Now, d theta by dx, d theta by dx, theta is tan inverse y by x. Tan inverse x differentiation is 1 by 1 plus x square. Now here y by tan inverse y by x. First we will differentiate through y by x and through x. Then through y by x it becomes 1 by 1 plus y square by x square. Means x square by x square plus y square into y into minus 1 by x square. Y by x differentiation is y into minus 1 by x square. Now x square gone. Now minus y by x square plus y square, that is r square, minus y by r square, that will sit here. Now d theta by dx, d theta by dy, d theta by dy, it will be same 1 by 1 plus y square by x square and then into 1 by x by dy. Now it will be x square by x square plus y square into 1 by x by r square. Here it is minus y by r square, here it is x by r square. Now dr by dx, r is square root of x square plus y square. Dr by dx, it will come as minus x divided by r x square plus y square, minus x by r, and this side dr by dy, it will be minus y by r. This will go and compute, if we cross side, then it will become y square y, okay, minus y by r. Here minus y by r, and here it is minus y by r square. It will become y square by r to the power 3, y square r to the power 3, and y square r to the power 3, and this side x, this side x, this will be x square by r to the power 3. If I settle it down, it becomes r square, negative sign we are omitting because Jacobian we don't take negative sign, it will be absolute value, r x square plus y square by r to the power 3, that will be r square by r to the power 3, 1 by r, and here forward Jacobian is r, forward Jacobian is r, and reverse Jacobian is 1 by r, 1. So dxy by d theta r into d theta r by dxy, it resolves in 1. So reverse Jacobian holds true, means reverse transformation holds true. Now we will proceed in the calculation of the Jacobian from the back side, that is d surface by dxy plane. We calculated dxy by d theta r. In normal xy plane we have z equal to fxy. D surface by dxy plane is dp by dx cross dp by dy. In if we have theta r plane and xy plane, then dxy surface by d theta r is dp by d theta cross dp by dr. We proved mapping point by point very meticulously, and then a vector and b vector, cross of a vector and b vector results in area vector. This is what we want. Now area vector divided by theta r plane into theta r plane, that theta r plane becomes d theta dr, and this theta r plane is d theta dr. That becomes now a vector by delta theta cross b vector by delta r, that becomes dp by d theta cross dp by dr as per the first principle of differentiation. So it holds true, means dxy plane by d theta plane is indeed dp by d theta cross dp by dr. Same thing will prove d surface area by dxy plane, this is what we say, will be dp by dx cross dp by dy, or other way, dp by dx cross dp by dy is d surface area by d XY plane. That we will prove, and one or two examples. We'll try to bind up in one more session. That's it. Then we will kind of proceed in either artificial intelligence directly, or whatever the invention we have done, means whatever new thing we have brought, some we will summarize in few sessions. Then we will jump into the much awaited artificial intelligence. Please support us. +91 9483160610. 91 +91 is India country code.